Alright, so we're working on this 2007 Corolla, looking at the AFR as well as the heated O2 sensor diagram. AFR has the AFR power and ground, as well as the heater going over to the PCM and battery plus, so the heater seems to be ground side controlled.
So coming off that wiring diagram, we're gonna look at the pigtail here for the O2 sensor that we removed on the Camry. And you got the pink heater wire here, the white signal, and then your grounds. And then the O2 sensor here with the connector. And then as you can see, the wires are different colors like we talked about in class. And then we removed it from back here next to the firewall. And then you can see the O2 sensor is a little dirty from all of the cold starts and tech use.
So we're back on this 06 Corolla. As you can see, the engine is still warming up. The ECT is reading 131 degrees right now. And for the O2 sensor output voltages, the PCM is currently supplying them a base reading right now. As you can see, the downstream is sitting at constant at 0.08. and the upstream is at 3.3.
We are still on the Camry here with our air-fuel ratio lambda or equivalence ratio, where the AFR is going to be dividing the car's air-fuel ratio to the base stoichiometric level, and whatever that is, it is going to be shown here, and it's going to try to get as close to 1. So if you have the 12.5 ideal AFR divided by the stoichiometric 12.5, you're going to get 1, as you can see here. But if you hit the throttle, you can see that there is some change to it. And if the line goes up like it did, it's going to be showing that it is leaner. And if it's going down, it is going to be richer, because if it's going up, that means it is above 1, which that top number in the division for what the calculation the AFR is doing is going to be higher, creating that higher spot on the graph.
So on this PID of the equivalence ratio, or the lambda reading, you can see as I gave the car some gas, it started to dip down more towards rich until I took my foot off the pedal and it spiked lean for a second because the PCM stopped supplying the engine with as much fuel.
So here we got that Camry, and it is up to operating temperature now. We got the blue line as our lambda and the orange is our short term. And I wanted to show how the blue line, the lambda, what the PCM is seeing, and how the short term fuel trim reacts off that lambda value from the PCM. So if you want to hit the gas, you can see that lambda value goes up, and then there's our short-term fuel trim showing that reaction from our lambda value going up and then down and evening out. And then how the short-term fuel trim comes back up and then goes back into that sine wave.
As we can see here, the equivalence ratio, or lambda, spiked lean for a second as I gave it gas, but we can also see the PCM respond by adding more fuel in the short-term fuel trim. As it added more fuel, the equivalence ratio settled back down more towards stoichiometric. Back on the 2006 Corolla, we're going to be creating a vacuum leak by pulling off the brake booster hose and seeing what it does to both our short-term fuel trim, bank 1 sensor 1, as well as our equivalence ratio for bank 1 sensor 1 as well.
As you can see, our short-term fuel trim spiked there, and so did our lambda a little bit.
Alright, so now we're doing the opposite on this 07 Corolla. We're going to be adding propane to the airbox to be creating a rich condition. As you can see, we have our equivalence ratio and our lambda pulled up here. As you can see in both these spots right here on our short term, it dipped very rich for a second, as well as slight dips in the equivalence ratio. As you can see, after it goes rich though, it spikes back up towards going lean, because PCM cuts all fuel once it sees the very rich condition and then goes lean and evens out.